these are the notes for lesson 2.4, day 2, and these are going to focus on direct variation. So if we recall that y equals mx plus b is a linear equation, again where m is the slope and b is the y-intercept, then y equals mx is a linear equation with a y-intercept of 0. So this is the same as y equals mx plus 0. Again, if the y-intercept is 0, we don't write it, so the equation is just y equals mx. This equation is used to show direct variation, where m is not equal to 0. Direct variation simply means that y increases as x increases. So if x is continuously growing or increasing, then your y value is going to increase as well. And that's just what direct variation means. This can be written as y equals kx, where k is the constant of variation. So again, just think of k as the slope. We just change it for direct variation. So example 1, you received 10 cents per can in Michigan for recycling. So we're going to write an equation to model this situation. So we don't know how many cans we're recycling, so we're going to call that x. We know that we get 10 cents per can. So y is going to equal 10 cents per can, 0.10x. So this is saying that this is direct variation because as the number of cans increase, the number of money that we receive is going to increase as well. So when we plug in values for x, or the number of cans, we're going to continue to increase the amount of money that we get. So the more cans that we deposit, the more money we're going to receive. So again, that's an example of direct variation. So we can write in equations for direct variation. So example 2, y varies directly as x, and y equals 15 when x equals 3. We're going to write an equation. So the first thing we need to do is solve for k, or find out what k is. Again, direct variation equation is y equals kx, where k is the constant of variation. So they give us a y value, and they give us an x value. So we're going to plug those in, and then we'll solve for our k value. So if y is 15, x is 3, we solve for k by dividing by 3. So k equals 5. Now our equation, again, should look like y equals kx. So when it asks for an equation, all you're going to do is plug in the k value that you solved for. So your final equation is just y equals 5x. So just to recap, again, they give us an x and a y value, so we plug that into the constant of variation equation to solve for our constant, or our k value, and then we just plug our k value back in, and that gives us our equation. Next example says y varies directly as x. I want you to cross out the cube of. If y equals 24 when x equals 2, we're going to find y if x equals 3. So we do this just like we did before. The direct variation equation is y equals kx. Again, they give us our x and y value to plug in so that we can solve for k. So 24 equals k times 2. Again, to solve for k, we're going to divide by 2. So k equals 12. So our equation is y equals 12x. Now, instead of asking for an equation, it asks us to find y when x equals 3. So from this equation, we're going to plug in 3 for our x value, and then we're going to solve for y. So y equals 12 times 3. So y equals 36. So this just tells us that if x equals 3, then y is going to equal 36 based on this equation that we found. So So again, direct variation just means that y increases as x increases. So if our x value is continuing to increase, our y value does as well. And this is just a special linear case.